Welcome to the Product School webinar. My name is Matt. I work at Chartio, and I'm talking about using data within your company. So a little bit about me. I've been a product manager for about 7 years. Worked in large companies, startups, and now at Chartio. I also am a part-time instructor at General Assembly teaching a class on data. So in my current role at Chartio, I both work again on product management activities, as well as I run our educational community that we call the Data School. And to give you a little bit more background on these two things I work on, if you're not familiar, Chartio is a BI product. We have a visual interface here that allows you to query and explore your data just by clicking around, and it generates SQL for you. We then can run that SQL against your database and then generate charts. So we can create interactive dashboards that you can share, comment on, and embed. Use it however you'd like. The Data School is a series of books. They're open books, so we're always adding to them. Both myself and people from the community contribute content to it. We edit it to make sure it's up to the right quality standard, and we cover a whole host of topics around how to successfully use data within a company. Most data education out there is career focused. We're more focused on companies becoming more effective users of data. So the point of this talk is really just to kind of give you a couple different ideas about how to better analyze data within your company. So the main two ideas here is to investigate statistics deeply, so not just kind of stopping at the first statistic that you see. And second is about how to avoid or at least help compensate for some of the cognitive biases that routinely make people's analysis not very compelling. So here I kind of took Steve Jobs' famous phrase of "stay hungry, stay foolish," and adopted it to a phrase that's more fitting for a data analysis mindset. So the phrase is now, stay curious, stay skeptical. So staying curious. So there's a lot of things when you join a company and you're working with data that can slow you down or can kind of looks like you're already done with your analysis. So things like seeing an average. You might think kind of your analysis is done. You found the average time on page, and I can report that out to my team or executives. Unfortunately, most statistics aren't as representative of the underlying data as you would think. So this image is showing you an example where the average would fall in the middle of this distribution, but if we look at this, an average that's in the middle wouldn't actually represent this data very well. We should probably break this data in two and have two separate averages. And this happens quite often. Averages are very sensitive to outliers, and as well as they can kind of be hidden with many different kind of peaks within your distribution. So you always want to look at the distribution to make sure, is my average or median or whatever summary statistic you're reporting, is it actually representative of the data? So again, always look at the distribution. I harp on this to my students at General Assembly and to everyone inside of Chartio. Another common problem is, so say you did look at the average and the distribution behind it, and it did look like it lined up well. It was fairly normally distributed, and the average is right there in the middle. One way that this average might actually still be sort of incorrect or misleading is that all of that data might be comprised of different groups. So let's say, again, average time on page. If we group that data by country, we might see the average be quite different for different countries. So maybe the US has 10 minutes, France maybe has 2 minutes, and our overall average is 5 minutes. And so does that overall average really feel appropriate anymore? You could then look at the distribution behind each of those countries to see even more. Do these statistics that we're reporting, are they representative? So you always want to segment your data to see if the statistic and distributions are consistent. So if it was an average time of 5 minutes and maybe the US was 5 minutes 5 seconds and France was 4 minutes 55, reporting the overall average makes sense. But if you have a high variance between what the segments look like, just giving the overall stat is actually kind of misleading about what's going on in your data. Another common stat that's kind of reported out that can oftentimes be misinterpreted is how some data is trending. So a lot of times people have their data scoped to a week or a month, some time frame that while it is relevant to a product work cycle, you're trying to see, did my new feature or new blog post, is it moving the needle on some metric? And so you might see, a dip or a bump in that number, and you might get very excited about it. Now the problem is, with that kind of scoped window, it's hard to put into context how big of a bump that really is. So you always want to, if you see any sort of signal, widen the scope of the timeline to make sure you're seeing something that's actually new. Instead of, if we zoom out here, we can see that this bump is actually not that significant given the context of the rest of the data. And so that it changes how we would talk about what we're seeing within just the month window time frame. So always evaluate trends on multiple timeline lengths. Basically, you should look at the data at as large of a timeline as possible that's still relevant. You don't need to go back, tens or hundreds of years for some application stat. You likely don't have the data for that. But you should kind of back out, couple months or maybe even a year or two. Especially going a year, more than a year, you can start to see potential seasonality consequences. So sometimes, for instance, with Chartio around the holidays, traffic dips because people would rather be with their family than looking at BI tools. And so getting out to that level also gives you some extra context as well. So we were just talking about reasons to continue to be curious about your data and not just kind of staying with what you're seeing, looking further into statistics. We also kind of need to have this mentality of staying skeptical. So any conclusions that we just kind of jump to, we should always be skeptical of those and kind of question, are there any ways in which my thinking about this could be biased? So the most dominant cognitive bias is called confirmation bias. And basically what this means is if you have some belief, you seek out data that confirms that belief. And so as a PM who's working hard to make their product better, you are actively searching for some chart that says your feature is making an impact. And so it's very easy to see a chart that is showing some number up and to the right and to get all excited about it and to report that out as a success. Now, the problem is looking at one metric does not give you a ton of context. Even if it is a statistic that is representative of the data behind it, it's a very narrow view into what's going on in your application. So you need to broaden the scope. You need to assume that any uptick you're seeing could possibly just be an error, and you want to check what other data would you need to see in order to feel 100% confident, maybe not 100%, but to feel very confident that indicator is actually happening and is improving your customer's experience with your product. So the general advice here is always look at multiple metrics before drawing conclusions, and that'll help you avoid kind of finding the single chart that looks good and sticking with it. If you at least expose yourself to more data, you have a better chance at better contextualizing your conclusions. Now, confirmation bias can even cause you to disregard that stuff, so kind of the backup plan to make sure you don't fall into this trap is just to have somebody who's less invested in the outcome to also look at the data that you did, and if they agree with your conclusion, then you're in a better position to carry that conclusion out to the company. So another common cognitive bias is selection bias, and this just really has to do with people being lazy. As a product manager, oftentimes you want feedback on some new feature, and getting feedback from people who are representative of your actual customer base can be actually quite challenging. It's definitely slow. And so what a lot of people do is they ask people around the office, maybe they ask a couple friends or colleagues to try out some feature. And unfortunately, if those people you're asking are actually representative of the data or of your customers, then their feedback is valid. If they're not, you could be kind of misinterpreting what your actual customers want. And so this is something you should always be asking yourself, is my sample representative of the overall group? If it's not, you need to try to discount what they're saying to a proportion that's consistent with how much that type of person is represented in the group. Another problem that PMs also face is that people who are really mad and people who are really happy are the people who tend to write in. So you see this with like NPS scores. You tend to get a lot on the top, a lot on the bottom, and not so much in the middle. And there's not a whole lot to do about this. You can't control, who all is going to respond to your surveys, but you should kind of assume that they are on the fringes, and that you kind of have this silent majority that is probably somewhere in the middle. So my advice is to assume a normal-ish distribution, and I would say, if people are mad, they're more likely to respond. So, skew that distribution slightly towards positive if you had a 50-50 split, because the negative people, if there are any, they'll be much louder, or there'll be more of them. So that isn't going to be quite as representative. So another interesting cognitive bias that plagues a lot of people's analysis is survivorship bias. And so the kind of classic example here is if you go driving around Europe or riding a train, you'll see castles, and if you asked yourself, what were most of the castles built out of across Europe? Now your answer is likely to be stone because that's the ones that you see. However, throughout history, far more castles have been built out of wood. They've just been either destroyed in wars or deteriorated, or for some other reason just aren't standing anymore. And so this has implications to being a PM as well. While it might not be super obvious on the face. And what it's asking us to think about is there data that you're not seeing? So, for instance, let's say you're asking people who sign up for your product and convert after the trial, what do they think of your product? And they might all say, this product is amazing. And let's say there's 5 of those people. And so you think hey, our product is great. Like, we're getting phenomenal feedback. What you're missing out on is maybe there's 100 people who went through the trial, and all but those 5 people thought your product actually wasn't any good. And so since you're not measuring the data throughout the experience, you're kind of measuring it only at the end. You're potentially only seeing a very small slice of what your actual data looks like. So again, the question you should be asking yourself is there data that I'm not seeing? Another variant of survivorship bias has to do with causality. And so here we have a coliseum, and at the end you have these very strong gladiators. And so some people infer from this that, oh, the Colosseum made these people strong. Now, what likely happened was the Colosseum rewarded people who were already strong and filtered out the weak. So the Colosseum didn't necessarily make them strong. It's just that the strong survive. So again, they're kind of the only ones still left around. So how does this apply back to being a product manager? So if you're building a tool, let's say like Chartio, where we're trying to make it easier and easier to use data, if we don't pre-evaluate people and determine if they're already skilled with data or not, we can't say if Chartio made them more capable of using data. If we didn't pre-evaluate and everybody could use data, we might think after using Chartio they could really do excellent analysis. We might come to the false conclusion that that Chartio made these people better at it. But if we do know that at the beginning no one was good at data, and then at the end they are good at data, then we have a larger claim that we can make. So that's my talk. I hope you learned something about both investigating statistics more deeply, not just accepting them on their face, looking at the distributions, how to segment it, and how to look at it on larger timescales. And I hope you also learned a little bit about how your mind works when it comes to looking at data, and how you need to avoid confirmation bias, selection bias, self-selection bias, survivorship bias. And these are just a small sampling of the biases that you can fall into. There's many, many more, but those are kind of the most prevalent ones I see, at least in my own analysis, that I often have to unpack. And lastly, I love talking about data, working with people on data. And so if you are interested in these topics, please check out the Data School. We have, again, a ton of free resources, an active Slack community where I'm in there chatting with people about these problems all the time. Also, feel free to reach out to me via email if, again, you have any questions at all about the data world, and or if you want advice about how to break into that industry. And I hope you enjoyed the talk, and have a nice day.